Hello there, my name is Mateos. Welcome to today's lesson on basic inorganic chemistry. In this video, we'll explore the concept of electrolytes and how they work in water. So what exactly are electrolytes? Electrolytes are substances that conduct electricity when dissolved in water. But how do they do that? Well, electrolytes work by ionizing or dissociating. This means they break up into ions in solution. There are two types of ions to keep in mind: positively charged ions, known as cations, and negatively charged ions called anions. For example, when sodium chloride, that is table salt, is added to water, it dissolves or dissociates into its ions. You can see this chemical equation here. NaCl, that's the solid salt, dissociates into Na+, which is the sodium cation, and Cl-, the chloride anion. Notice the Aq next to the ions. That stands for aqueous, which means the ions are now surrounded by water molecules. These ions move freely through the water, and because they are electrically charged, they allow the solution to conduct electricity. Now, let's dive into three important types of compounds in inorganic chemistry: acids, bases, and salts. First, let's talk about acids. Acids are substances that, when dissolved in water, release hydrogen ions H+, which usually exist as hydronium ions H3O+, when they combine with water molecules. This means that H+ or H3O+ is the only type of cation they produce in solution. For example, when nitric acid is added to water, it dissociates as follows. We are left with a solution of H3O+ ions, the hydronium ion, and NO3-, the nitrate anion. Next, let's look at bases. Bases, on the other hand, release hydroxide ions, that is OH-, as their only anion in water. A classic example is potassium hydroxide, KOH. When solid KOH dissolves in water, it dissociates like this. Here, K+ is the potassium cation, and OH- is the hydroxide anion. Now, when an acid and a base react together, they form a salt. Salts are the product of this acid-base reaction and contain the cation from the base and the anion from the acid. For instance, reacting potassium hydroxide with nitric acid will yield potassium nitrate as the salt. Here, K+ is the cation from the base, and NO3- is the anion from the acid, forming the salt KNO3. So acids give us H+ or H3O+. Bases give us OH-, and when they react together, they form salts. Now that we've discussed the basic categories of acids, bases, and salts, let's dive deeper into electrolytes and look at the differences between a strong and a weak electrolyte. Let's begin with strong electrolytes. A strong electrolyte is a substance that completely ionizes or dissociates when dissolved in water. This means that almost 100% of the compound breaks up into ions, which makes the solution a good conductor of electricity. There are three main types of strong electrolytes: strong acids such as hydrochloric acid, nitric acid, and sulfuric acid. These acids dissociate completely in water to release H+ ions and their corresponding anions. Strong soluble bases like sodium hydroxide, potassium hydroxide, and lithium hydroxide. These bases dissociate completely as well to release OH- ions in solution. Finally, we have soluble salts, such as sodium chloride, potassium sulfate, and calcium nitrate. These salts also dissociate completely into their respective cations and anions in water. Because they fully ionize, solutions of strong electrolytes have a high concentration of ions and can conduct electricity quite well. Weak electrolytes, in contrast, only partially ionize or dissociate in solution. This means that only a small portion of the electrolyte molecules break up into ions, leaving the majority of the compound still intact in its molecular form. As a result, weak electrolytes conduct electricity much less effectively than strong electrolytes. Some examples of weak electrolytes include weak acids such as hydrogen cyanide, hydrosulfuric acid, and phosphoric acid. These acids dissociate only partially, so only a small fraction of the molecules release H plus ions in solution. An example of a weak base would be ammonia. Ammonia reacts with water to form ammonium ions and hydroxide anions, OH-, but again, only a small amount of the ammonia molecules undergo this reaction in solution. Because they do not fully dissociate, the concentration of ions in a solution of a weak electrolyte is much lower, and as such, their ability to conduct electricity is much weaker. Now, let's take a closer look at one of the most important types of reactions involving electrolytes, neutralization reactions. A neutralization reaction occurs when an acid reacts with a base to form a salt and water. This is a key reaction in both chemistry and many practical applications, including titrations, antacid treatments, and even in biological systems. Here's how it works. The acid donates H plus ions and the base donates OH-. When these ions combine, they form water, and the remaining ions form a salt. Let's look at a few examples. Notice that some bases like calcium hydroxide and magnesium hydroxide can release 2 or more OH- ions in solution, and some acids like sulfuric acid can release 2 or more hydronium ions in solution. Now let's explore another important type of reaction involving electrolytes, precipitation reactions. In a precipitation reaction, two aqueous solutions of electrolytes react to form an insoluble salt or insoluble base. This reaction occurs when the ions in a solution combine to form a solid product known as a precipitate, which is insoluble in water. Here's how it works. When two ionic compounds dissolve in water, their ions separate and float freely in the solution. If two of these ions combine to form a compound that is not soluble in water, that compound will precipitate out of the solution as a solid. Let's look at a few examples of precipitation reactions. Silver nitrate reacts with potassium iodide. In this reaction, Ag+ and I- ions combine to form silver iodide, AgI, which is insoluble in water and precipitates out of the solution. The remaining ions, K+ and NO3- stay in solution. Same thing happens when we react magnesium sulfate with barium chloride. Here, the barium and sulfate ions combine to form barium sulfate, which is another example of an insoluble salt. Lastly, let's look at the reaction between sodium hydroxide and zinc sulfate. Zinc hydroxide, like most metal bases, is insoluble in water, so in this case it'll form an insoluble precipitate, while Na2SO4 stays dissolved in solution. Now it's your turn. Let's practice. Pause the video and see if you can answer all of these questions. If anything is still unclear, feel free to watch this video again. Thank you so much for watching this till the end. Be sure to check out our next video, where we'll explore the fascinating silver tree, a stunning reaction between silver nitrate and copper metal. We'll also dive into why iron rusts and take a closer look at hydrogen fuel cells, an extremely flammable yet exceptionally clean energy source. Could hydrogen be the fuel of the future? I'd love to hear your thoughts in the comments below.